In this video I'm going to be working an individual limit problem. It is going to be a trig limit, and in working out this problem I will be using this trig property, the limit as x approaches 0 of sine x over x equals 1. And I'm also going to write this double angle formula down ahead of time because we are going to ultimately use that. Cosine of 2x is equal to 1 minus 2 sine squared of x. Alright, that's a pretty common double angle formula, and you're going to find if you do a lot of trig limits that knowing those trig identities are really going to be helpful, so that just when you see something like cosine 2x, then it might be worth your while to see if there is one of those identities that can be substituted for it to make the limit a whole lot easier to do. Alright, now as with any limit, you should always do a direct substitution first to see if that's the easiest approach that you can take and you'll get an answer, or whether you've got more algebra steps that you're going to have to do. Doing a direct substitution on this, I would take 0 and I would plug it in. That would be giving me a cosine of 0 minus 1 all over 2 times 0 squared. That denominator obviously is going to be a 0. Cosine of 0 is 1. 1 minus that 1 on top will give me that 0 over 0 indeterminate form. So then I do know now that I have to do some algebra manipulation here to get this limit to work out. Now, this double angle formula, right there I have a cosine of 2x. So I am going to replace it with that double angle formula. So then I'm going to have the limit as x approaches 0, replacing that with what it equals, 1 minus 2 cosine squared x, and then minus 1 that's in that original limit, all over 2x squared. Alright, so from there I can start simplifying. 1 minus 1 is going to cross out right there. And then maybe we can do this all in the same step here. I then have a negative 2 and a 2 here in the bottom, so the 2's will cross out as long as I don't forget about that negative. The 2 and the 2 is also going to cross out. Alright, so from there I can do the limit as x approaches 0 of negative sine squared x all over x squared. Simplified there. Now I need to try to manipulate this so that I can get a sine x over x. Well, I've got sine x squared in the top, I've got an x squared in the bottom, so I definitely have two of both of those, so I can create sine x over sine x by just manipulating this rational expression right here. Now the negative there, I am going to go ahead and pull that out in front as a negative 1 because that's just going to mess things up. It's a constant. We can go ahead and get that out of there. So I'm going to have a negative 1 times the limit as x approaches 0. Alright, one of those sine x's over one of the x's on the bottom, and then the other sine x over the other x. Alright, as long as I can take a rational expression, break it up into two things that are being multiplied together, as long as these two things multiply to that rational expression, I have algebraically maneuvered that problem an accurate way. Alright, now, probably wouldn't hurt to put an extra line in here. Negative 1 times the limit as x approaches 0 of sine x over x, and then times the limit as x approaches 0 of sine x over x. And multiplying those two things, I can break those up into individual limits. Alright, because of my properties, I know that this is equal to 1. I also know that that is equal to 1. So, for a final answer here, I'm going to have negative 1 times 1 times 1, which will result in an overall limit of negative 1. So just a couple different a property that you had to use of limits, and then a trig identity that you needed to use for substitution there. So definitely thanks for watching. If the videos are a help to you, please share with your friends so that other people can benefit as well, and also try to get people to subscribe to the channel. Thanks.